Okay. Can you guys see my screen? Okay. So the main basics that you need to keep in mind is number systems may. Hmm. Right. So first thing is you have something called positive numbers, and other one that you have is negative numbers. Right. Two types. Okay. So there is no special representation for the positive numbers. No special representation. But for the negative numbers, you have something called sign magnitude representation. Then you have ones complement representation. Then you have two's complement representation. Okay, so I'm talking about binary. Okay, so let me take some example. You want to write no. Now see, we're talking about sign magnitude form, ones complement form, two's complement form. So we have to define the number of bits that you use. So let's say you use 4 bits for the entire representation, you stick with that. Okay. Let's say, for example, I want to represent number plus 7 in binary. In binary. This we know, this is 0, triple 1, right? This we know already. Sign magnitude form. Okay. So there is a MSB. This is MSB. And remaining 3 bits, right? These 3 bits, this is for the magnitude. Okay. So typically this goes like this. Okay. So the 1 bit is for sign because positive or negative, that's all, right? Only two things are there. Okay. So if I write, okay, one now if you take the same representation here, 4 bits are there, no? These 3 for magnitude, this is for the sign, right? Now if this is 0, that means that this number is positive. This is 1 means this number is going to be negative. So let's say I want to write plus 7 in sign magnitude form. It's remained the same, 0, triple 1. There is no change. And no need to discuss about that also. Let's say I want to write minus 7 in binary. On that in sign magnitude form, right? So this is minus. So obviously you write 1 here. And you know the magnitude of this 7, right? This 7 can be converted, right? 7 in decimal is equal to what in binary? 1, 1, 1, right? So 1, 1, 1, 1. Right. So if I erase all this, so minus 7 in decimal is equal to 1, 1, 1, 1 is nothing but this is 4-bit sign magnitude form. Right. So far so good. But what about what is the issue with the sign magnitude form? Why we are having one's complement or two's complement? So the issue is this. Okay, according to the convention that I have told you, let's say for example 0. Let's say I want to write plus 0. Looking at the sign, first bit is going to be 0. Then remaining 3 bits are magnitude. What about minus 0? looking at the sign 1, looking at the magnitude again 0. That means we know that plus 0 is equal to minus 0, that is equal to 0. It's all same. But the 0 has two different representations. This is the problem. A same number has two different representations, which is very much confusing when it comes to computation and all those things, right? So they are not fairly acceptable system. Are you guys with me? Please message in the chat box, yes or no. Okay. Right. So let's go to one's complement. How does that work is, let's say I want to have minus 7 representation in one's complement. I mean, that is binary. See, I'm talking about binary system. Same concept you can some concept can be applicable to decimal number systems as well. So how to represent minus 7? So what you do is, first write what is plus 7 in 4-bit magnitude form. 0, 1, 1, 1, right? So how to get minus 7 from here is, right, subtract 1 from each, okay? Let's say 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. I'm just telling you, there is a formula called R power, this n minus, so don't worry about all those things. I know you will anyways get it, okay? Don't worry about that. So just 2's complement form, I mean 1's complement form, push. Oh, I erased all the ink. Fine. So we have sign magnitude, we have 1's complement, and we have 2's complement, right? So we understood the issues. So now what I'm trying to do is I'm trying to work on how to get minus 7, right? So for that you need plus 7. Plus 7 representation is 0, 1, 1. Okay. Then to get minus 7, subtract 0, 1, 1 from 1, 1, 1, 1. If you subtract that, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0, right? This would be the representation, right? So again, what is the issue? Why we are going for 2's complement? What is the requirement? Again, if I say plus 0, representation of plus 0 is 0, 0, 0, 0. Minus 0 is subtract these zeros from 1, 1, 1, 1, right? 1, 1, 1, 1. Again, you see it has two representations. 0 has two representation. So 0 has two representation in sign magnitude form. 0 again has two representations in uh, 1's complement form. All right. So what is 2's complement form then? Very simple. You find out 1's complement and plus 1 to that. Add 1 to that. That's all. That is nothing but a 2's complement form. So for minus 7, how to do that? So first you find out plus 7. What is the representation? 0, 1, 1, 1. Sorry. 1, 1 is extra. Then get 1's complement. How to get 1's complement? 1, 0, 0, 0. Add plus 1 to that. Plus 1. 0, 0, 1. That's it. 1, 0, 0, 1. Okay. Now let's see whether 0 has how to get the whether 0 has two representations or not. So let's talk about plus 0. According to the definition, okay, I'm taking plus 0, right? Now minus 0, what to do? 1's complement. What is 1's complement of that? 1, 1, 1, 1. Then add plus 1 to this. 1 plus 1 is 0, 1, 0. Sorry, not 0. 1 plus 1 is 2. In binary, it is 1, 0. Again, 1 plus 1 is 2. Again 1, 0. Again 1 plus 1 is 2, 1, 0. Again 1 plus 1 is 2, again 1, 0. How many bits you are fixing? Only 4 bits you have to take, right? So if you take 4 bits, this is what it is, right? Plus 0 has representation 0, 0, 0, 0. Minus 0 has representation 0, 0, 0, 0. That means the representation is same, correct? So that's where the 2's complement will make the things very much clear, right? Even though plus 0 and minus 0 look wise they are different, right? But the magnitude is going to be same, right? We all know that plus 0 is equal to minus 0, that is equal to 0. Which 2's complement has uh, certainly maintained that kind of uh, you know representation, because plus 0 has 0, 0, 0, 0, minus 0 has 0, 0, 0, 0, right? That's where the 2's complement wins over 1's complement and sine magnitude form. Right. So these are the simple basics of why we need to go for a system. Now let's come back to this. Okay. Let's say if you want to find out 10's complement, you find 9's complement, add 1 to that. Okay. How to find 9's complement? Take that number 0, 1, 4, 3, your favorite number, subtract it, plus 1 to that. That will become 10's complement of minus 1, 4, 3. Okay. Something like that. It's very easy. Okay. All right. So, these are the things that I wanted to discuss. Then, okay, let's dive into the problems. Have we seen these problems last week? I'm not sure. Last week. Bunty, can you please clarify? Or if you guys are okay, we can discuss once again if newcomers are there. Oh, is it? You have seen it already. Okay, this one, 7-bit 2's complement representation. Have you seen this one? What is 7-bit 2's complement representation of 43? Yes, okay, fine. This one, two numbers are represented in 2's complement, sine 2's magnitude, 2's complement form, p equal to this much, q equal to this one. Q is subtracted from p. I think we have seen these problems, I think. Okay. Then this one is like very simple, we have discussed already. Which of the following has only one way to represent 0? Can you answer this now? Which of the following has only one way to represent 0 in its number form? Yeah. So what's the answer? We already discussed, right? So very good. Ah, do this one. The subtraction of a binary number k from another binary number m is done by adding 2's complement of k to m, and it results in a binary number without overflow. This implies that result is. Very good question. The subtraction of a binary number k from another binary number m is done by adding 2's complement of k to m. Option D. Positive and is in normal form. Okay. A. Positive and is in. Oh, nice. Then it's a good problem. By the way, did you guys understand what is this overflow thing? Right? So let's discuss on that. It is very, very important also. So let's say for all the discussions that we limit our discussion to 4-bit representations. Okay. This is 2's complement form, right? So let me divide into 4 quadrants. Let's say I have +4 and +2. Hmm? Then there is +7 -3. I have +7 +7. Hmm? Then I have -7 -7. So we all know these answers, right? Already. What a funny question is this, right? So let's do it in the 2's complement form. Right? +4. What is 2's complement form? 4-bit representation is what? It is positive number, right? So no special treatment for that. Again, positive. 0 0 1 0. Are you guys with me? 0 1 1 0. Right? So now this is in binary, right? Then if you convert, you will get 6, right? Hmm? Now you have +7 and you have -3. Now this +7 -3, I can write it as +7 plus -3, right? Instead of subtracting it, I can just add -3 representation to 7, right? So what does it mean if I do 2's complement? 2's complement of 7 plus 2's complement of -3, right? In 2's complement form addition. This is 2's complement addition, okay? You understood the concept, right? Okay. So what is representation of, where is this? Okay. I am running out of colors, man. No color in life. 0, 1, 1, 1. What is -3? How to get -3 representation? For that, you need to know +3, right? +3, 0, 0, 1, 1. 4-bit only, right? 4-bit representation. Then you get the 1's complement. This will become 1, 1, 0, 0. Plus 1 you add. Okay, this is 1's complement plus 1, right? So 1, 0, 1, 1, right? 1 0 1 1. What does it mean? 1 0. 1 plus 1 is 1 0. 1 plus 1 plus 1 is 1 1. 1 plus 1 is 1 0. Now if you look at this 4-bit representation, if you take only 4 bits, you have 0 here. That means this is a positive number. So if it is a positive number, take it as it is. This is 4 and we know 7 minus 3 is 4. Right? Let's go here. You have plus 7, right? What is the representation? 0 1 1 1. What is plus 7 here? 0 1 1 1. So no major changes. Okay, 2's complement of plus 7 is same as plus 7, right? 1 1 is 1 0. 1 plus 1 is 1 0. 1 plus 1 plus 1 is 3. That is 1 1. 1 plus 1 plus 1 is 3. That is 1 1. Then this is 1. Now according to our understanding on 4-bit representation, right, in the 2's complement, if I see this is the number, means that is negative number. Right? That's how the 2's complement logic work, right? So how to get it back? You apply again 2's complement on 1110. How to know the number? So what I mean to say is this. Right? Here we discussed, right? So 2's complement of minus 7 is what? 1001, right? Now somebody told you, you don't know this, right? Somebody told you, I have a 2's complement, 4-bit 2's complement of a number x is 1001. They'll ask you how to find x. What is x? So what will you do? You look at this number, okay? The MSB. You look at the MSB bit, most significant bit. It is 1, right? Means that I am sure that this is a negative number. So since it is a negative number, they would have done the 2's complement, right? You have to do reverse engineering. So what you do? You again do the 2's complement of 1001. What will do? 0 1 1 0 plus 1 1. This means this is the magnitude. I know by looking at this negative and the magnitude is 7. So that number x is going to be minus 7. So means you do the reverse 2's complement again, back on the number that is given. The number that is given is 1001 in 2's complement form. I did 2's complement again. Okay, I got the magnitude. That's where I concluded that number x as minus 7. Now I am coming here and asking you the same thing. Somebody gave you 1110 and asked you what is the number in decimal. So by looking at this, you know that this is going to be a negative number, right? Now how to do that? How to find out the magnitude? You get the 2's complement of 1110. What is this? 0 0 0 1 plus 1 you add, okay? 0 0 1 0. So the result of this, according to our understanding, is minus 2. But according to this is plus 14. Everybody knows. Means something wrong here. This is something wrong. Just keep there. Similarly, you go here. This is nothing but what? Minus 7 plus minus 7, right? If you know 2's complement of minus 7, 2's complement of minus 7, you add those two. That's all. Okay. So minus 7 2's complement representation we already found, right? What is it? 1001. Correct? 1001. Again for this is 1001. And add these two. 1 1. This is 1 0. This is 1. This is 0. This is 1 0. Okay, 1 plus 1 is 2. Now if you look at this number, if you look at this, the MSB is 0. MSB is 0. That means what? The number is going to be positive. How to get the magnitude? The remaining bits, right? So 0 1 0 is what? 2. According to this, answer is 2. According to this, answer is minus 14. Means something wrong. In these two cases. Can anybody guess Why there is something wrong? You can unmute your mics and then talk. Due to carry? Yes, you can say, but that's not exactly. I understood what you're trying to say. Now, I'll tell you a typical real-time example. You guys might have ride a bicycle or scooty or whatever. Let's say, for example, you are riding a cycle and the maximum load is two people, and all of you know. Suppose if there are four people sitting on the bicycle, I'm sure most of you have experienced, and most of the people who are watching us would have told us what's wrong with you when we are driving, when we are, you know, four people riding in a cycle, correct? It's called overloading. Are getting it? So there is something called overloading happening here also. What do I mean by that? Is this? Let's say there is a 4-bit representation, right? We discussed, we taken 4-bit representation in 2's complement. So what are the range of numbers that I can represent using this? So if you take 4 bits, these are the possible forms, right? Correct? Now what I'm telling is, don't think as a binary and all. I'm just saying these are the 2's complement forms. These also a 2's complement form. I'm just giving. Now what you do immediately, you look at the MSB 0. That means that this is positive number. So you make it like this: +1, +2, +3, +4, +5, 6, +7. Now what is this number? Look at this. Means that is a negative number. Since it is a negative number, you apply 2's complement again. If you apply 1's complement, you will get 0 triple 1, then +1, 1 0 1 0 1 0 1 0. What is the magnitude of this? 8. Correct? So -8. Then this one will be 0 1 1 0. This is -7, -6, -4, -4, -3, -2, -1. So for a 4-bit representation, right, I can go lower is -8 to highest is +7. This is the range of numbers I can represent. -8 to +7. But what is the result that I'm expecting here? +14. But what is the result I am expecting here? Minus. That is what I'm saying. Something wrong. Now you look at this result. This is fine, right? Why? Because this is in the range of -8 to 7. This is also fine, right? Because that result is in the range of -8 to 7. This is called as what? Now you understood what is this called as? Overflow. Right? So what are those? Overflow. These are the two examples where the overflow has happened. Right? So this is scenario 1, 2, 3, 4. So overflow happened in the scenario of 3 and 4. No overflow happens in the scenario 1 and 4, 1 and 2. right? So when the question says without overflow means the process is correct. Okay, there is no issue with the process. Okay, this process is right. Right? They did everything nicely means they are taken care of the overflow. Are you getting it? So there are overflow detection circuits. Okay. So there are many ways people can detect the overflow, right? Now, for example, okay. Anyways, I have discussed this much. Let's go to another example. I'll also tell you, I think, how plus 14 and minus 2 are connected. Okay, I'll just discuss that in a bit. Let's say, for example, you have two representations. Okay, two, two's complement representations. One is A, another number is B. This is A3, A2, A1, A0. Okay, 4-bit representations. B3, B2, B1, B0. Hmm? Now, how to detect a overflow is the question. How to detect overflow? And I am also giving you the result C0, C1, C2, C3, and this is C4, the output carry. And here, this is C, okay, the carry that is generated from this stage. Okay, let's say C aux, C aux. Okay, so that is the input carry. Or I can also say, okay, why to confuse you guys? I'm not here to confuse. Let's say C in, that is input carry. This is the output carry. So the result is going to be C3, C2, C1, C0. How to detect the overflow? Now I gave you all the number, all the digits, all the numbers, everything, right? A3, A2, A1, A0, B3, B2, B1, B0, C in, C out, C3, C2, C1, C0. Now look at this example. What does this example say? 0, 1, 1, 1, 0, 1, 1, 1. So what is the result that you got? 1, 1, 1 here. 1. What is this? 1, 1, 1, 0. 0. Now try to say how to detect a overflow. Three input and and there is one more condition also, no, that you got a overflow. In these two conditions, we observed something wrong, right? Something wrong. Now I am trying to find out Boolean expression for overflow, how to detect overflow. This is a 2-mark question, okay? And many times it keeps coming up. Now this is what you need to look at it carefully. Now if I compare this and this example, right? In this example, let's say this is example 1. Hmm? This is example 2. Let's talk about example 1. Hmm? For that I use a black pen. Now you look at this, if you look at this example, what is the C out? 0, correct? Because this is the C out, right? The output carry. What is the C in? Is 1. In the example 2, if you look at it, C out is 1, C in is 0. Now let's go back to no overflow condition. If you look at no overflow condition, C out and C in, if you observe, here C out is 0, C in is also 0. Here C out is 1, C in is also 1. Are you getting it? I'll write it there. In no overflow or everything is perfect, C out is 0, C in is also 0, C out is 1, C in is also 1. Based on C out and C in, can I formulate some formula for overflow? Can you guys guess it now? Exactly, perfect. Suppose if I put an XOR gate for C out and C in, I can detect whether the overflow exists or not. Right? So put a XOR gate. This will give you overflow. That's it. No need to do anything. Okay. Anything else that you guys observed? Is it the only way? Okay. I'll just give you the hint. You see this? If A3 is 0, B3 is 0, let's say if A3 is 0, B3 is 0 and C3 is 1, then overflow. Yes or no? Did you guys agree with this? If A3 is 0 and B3 is 0 and C3 is 1, then definitely there is a overflow. Yes or no? Agree, yes or no? Type in the chat box. Hey guys. Yes or no? Can you guys hear me? Okay. So what I'm saying is this. If A3 is 0, B3 is 0, C3 is 1, then there is a overflow. Do you guys agree? Or if A3 is 1, B3 is 1, C3 is 0, again there is a overflow. Right? So what I'm saying is this. Forget about C out and C in for some time. Now look at this. There is one more concept I'm teaching. If A3 is 0, B3 is 0 and C3 is 1, then there is a overflow. Do you guys agree or not? So how can I write that overflow condition here? A3 complement. If A3 is 0 means A3 complement, right? B3 is 0 means B3 complement. And C3 is 1. Okay, this condition will give you overflow. Or what is the other condition? If A3 is 1, B3 is 1 and C3 is 0. That means A3, B3, C3 complement. This will also give you overflow. You guys understood this or no? Quick, guys. You need to respond fast, okay? Okay. So we have two conditions. I mean, why this is coming up here is this very simple, okay? Now 0, 111 is a positive. Let's say A3 is 0 means I know that A is a positive number. B3 is 0 means I know B is a positive number. What is the result of two positive numbers? Definitely a positive number. But if C3 is 1, that means that it is a negative number, right? That is the general sense I'm saying. Is the result of two positive numbers can ever be negative number? Impossible. Yes or no? Similarly, if A3 is 1 means A is a negative number. B3 is 1 means B is a negative number. Two negative numbers if I add, I will get a negative number. But what is the result saying? If C3 is 0 means result is a positive number. Two negative numbers cannot give a positive number. Yes or no? That's why. So either you can use this expression, C out XR of C in, or you can use this expression. Everything. I mean, both the things will give the same thing, but generally we prefer, C out XR of C in because it's a simple two input XR gate. Otherwise, you have to take a three input AND gate, one more three input AND gate, and one more OR gate, then NOT operation, all those things has to be done, right? Now, why this? I mean, just out of people might be curious how this plus 14 in the place of plus 14 minus 2 has come. Now, if you look at this, I'll just you want to know that answer? How in the place of plus 14 minus 2 came? Or I'm just keep it, just give it to leave it to you. Okay, I just leave it to you because it will take 5 more minutes to explain that. Okay, now you tell me the answer. So there is a bit of ambiguity in this question, so which we need to correct very clearly. They're saying the subtraction of binary number k from another binary number m is done by adding 2's complement of k to m, and it results in a binary number without overflow. But they didn't comment about the output carry. Let's see this example, right? Now forget about these overflow conditions. Now this doesn't apply. Now you look at this here, right? So let's say for example, you look at this example, plus 7 and minus 3, right? It is like m minus k. And you look at this, there is no overflow in this, and there is output carry, C out, correct? Which I think that is what is missing. Okay, they didn't mention something about C out, whether that is there or no or something, right? Accordingly, you can choose the answer, right? So if C out is 1, then you can say the answer is positive. Let's say C out is 0, then you can say, it is in 2's complement form and answer is negative, right? Negative and is in 2's complement form. So why am I saying this is, okay, see this typical example you take. Mhm. We have already seen plus 7 and minus 4, right? This is this one. Then 0, 1, 0, 0 is 4. And 1's complement is 1, 0, 1, 1 plus 1, 1, 0, 1, 0, 1, 1, 1, 0, right? 1, 1, 1, 0. This is 1. I am adding these two, right? Then 1, 0, 1, 1, 1, 0, right? What is the answer? Huh? Ouch. Something wrong. I messed it up somewhere. Hmm. Okay, plus 4 is what? 0, 1, 0, right? Its one's complement is 1, 0, 1, 1. Now you add plus 1 to this. 1, 0, 1, 0, 1, 1. Okay. So this is 1, 1, 0, 0, right? Now you add these two. Addition. 1, 1, 1, 0, 1, 0. Okay. Now this is plus 3. And you know this is okay, fine. I'm just choosing the number such that there is no uh, overflow, right? Now minus 4, minus 7 plus 4. How to do that? Minus 7 we already know the 2's complement representation. Plus 4 we know already 0, 1, 0. This is 1, 0, 1, 1. Now you look at this. In these two conditions, here C out is 1, output carry. Here C out is 0. We all clearly know that when C out is 1, and of course no overflow, we already checked it. C out is 0, and of course no overflow. That means that if C out is 1, the result is going to be a positive, right? On normal form. If C out is 0, then the result is going to be, we know already this is negative. Since it is negative, it is in 2's complement form. To know the exact value, what we should do, we should apply 2's complement to 110, 2's complement of 110. And I know because this is already negative. So this is 0, 0, 1, 0 plus 1, 0, 0, 1, 1. Okay. This is minus 3. Are you getting it? So I think in that question, C out information has to be given. Otherwise, it's difficult to comment about it. So in that case, people should be very clear about what exactly they're asking. Okay, are you guys clear? Type it in your chat box. Yes or no? Okay, all right. Now let's move on. Well, and all those things. You guys want to give a try to this? Assuming all are in one's complement, two's complement. I think we have discussed that. Okay. That's all. Summary of all those two's complement stories. Think about this one. Okay. So this is a number system. Now we have to add these two numbers in base 4 number system. Okay, option D. All right, let's see. Okay. Okay, sir, for example, in base 10, let's see. Let's say I have this number 18 and I have number 99. So 9 plus 8 is 17, right? So what will you do? You write 17 here. 9 plus 1 is 10. You write 10. So the answer is 1017. Is that how you do? It is absolute nonsense, right? Wrong. So what generally we should do? 9 plus 8 is 17. So the carry comes here and the 7 here, 7 is there. And 9 plus 2 is 11, right? Carry comes here and the result comes here. So the answer is 117. Similarly, if you look at base 4 addition, the maximum possible number in that is 1, 2, 3. This is the maximum number. Everything else is a combination. So how to write 4 in base 4 number system? Okay, 4 in decimal. How to write it in base 4 number system? Can I write 1, 1? Yes or no? 1, 1 base 4 or 1, 0, sorry. 1, 0. Right? We can write as 0 into 4 power 0 plus 1 into 4 power 1, that is equal to 4. If I know one, if I write 104, 10 base 4 in the base 4 number system, that is equivalent to 4 in decimal number system. So 3 plus 2 is 5. How to write 5 in base 4? 5 is in decimal. How to write it in base 4? 1, 1. So what about 1 plus 2 plus 1? 4 is 1, 0. What is this? 3 plus 3 plus 1, 7. 7 base 10 is equal to, can I write 1, 3 base 4? Yes or no? This is 4 power 0 position. This is 4 power 1, 4 plus 3, 7. 1, 3. So if I sum it everything, I can write 1301 base 4. So the option D is right answer. Okay. Do we have any questions? Okay. Then, so the base of the number system, they told they added these two numbers and the result is for 1. What should be the radix or base number system? Okay, guys, what's the answer? What do you think? Last 1 minute, okay? I will explain this. So 4 plus 4, we know it is 8, right, in decimal. Now, according to this number system, this is 1, the LSB is 1, and anything else is here. There should be something that comes here to make it this 4, right? So I think this is 1, right? 2 plus 1 plus 1 is 4, correct? So 4 plus 1, 4 plus 4 is 8. 8 in decimal is equal to 1 and 1 base x. Agree or not? Let's assume some number x. So if I convert this into decimal, this is 1 into x power 0 plus 1 into x power 1, that is equal to 8. So x plus 1 is 8. So the x is 7, right? So 2, 4, 1, 4, correct? 4 plus 4 is 8. In 7 number system, this is 1, 1, 7, right? 1, 1. So 2 plus 1 is 4. Okay, this is also true. This is also true. This is also true. Everything holds good. Options B is the right answer. Okay, guys, I'm stopping it here. If you have any questions, you can ask me. Come on, shoot out. I'll just give you 2 minutes only today. Okay, if you don't have anything, okay, chalo. Tata, bye bye. Okay, welcome, Ramesh. Okay, Bunty, the questions that you have sent, no, I will discuss. I'll discuss in the next class. I think today we are running out of